Hey guys, so in this one we're going to be looking through binary search very quickly. We're going to be looking into how we actually program it. Now there's a previous video on the theory, so go with that if you like. And again, there could be multiple solutions to the same answer or to the same question, so don't rely on it being exactly like this. However, first condition is that our array must be sorted. Now, luckily, we're using Python, so I can just do numbers.sort, and then if I print numbers, you'll see that it has sorted the array for me. Now, in theory, you can use this as an exam. I'd suggest if you do know it, write it out longhand. Okay, so now that I've done that, I need to go back to what I was thinking before, and I need to get my variables. So declare and init. So I'm going to have lower, as I said before, and it's going to start at the lowest point, and that's going to be an integer. I'm going to have upper, and that's going to be equal to the length of numbers minus 1. Okay, so we're going to get the length of numbers, which 1, 2, 3, 4, 5, 6, 7, 8, but because we start at 0, 0, 1, 2, 3, 4, 5, 6, 7. So we have to subtract 1 to change the upper value to the index. Now we're going to have mid, but we're going to calculate mid later, but let's just declare it anyway. Integer. So let's declare it anyway, and stick all of these as integers. We're going to have the sort value, that's the number they're looking for. Again, let's put it in minus 1, put it as an integer. Is there anything else I need? Possibly, but I can come back to it later. Oh, I'm going to need a variable found, which is either going to be true or false. It's going to start false because we've not found it. And that's going to be a boolean. I'll explain that one a bit later. Oh my god, my spelling is more atrocious than normal, which is a big thing. Declare. It's been a long day at school. Alrighty, so we get lower, upper, mid, sort, found. So the first thing we have to do is ask what number to find. And that's going to be sort equals input, enter the number to find. Now, I don't think for paper 4 you get marks for comments, but it really does help to do them. Just A, it explains to you, but B, it explains to the examiner what you were thinking. So you might get marks even if you mess stuff up, if they can understand your logic behind it. Who knows? Okay, so we're going to ask them to enter the number to find, and then I'm going to look through this. So I'm going to loop through it. So I'm going to say while not found. Okay, so that's this value here. So basically, if it's not been found, keep repeating this code. Now, previously we said, I'm going to take the midpoint, and I'm going to make that be equal to the upper plus the lower, and it's going to be integer divided by 2. Now, I have to be careful here, because I want to be adding them together first, and then dividing it. I don't want to divide lower, and then add the upper. I want to add them together and then divide it. And it's important to note that it is integer division, which is, so if I had, let's say I had 11 puppies, and I had 2 people that wanted to buy the puppies. Okay, so let's go over here. 11 divided by 2. So if everyone gets, each of the 2 people get 5.5 puppies, which means we're cutting a puppy in half, you sickos. So we don't want to do that. So what we want to do is we want to divide it as much as possible with a whole number, and then we're going to have a remainder of 1. So this is going to actually be 5 remainder 1. Okay, and if you want to get the remainder, remember you could use the mod to get the remainder. Anyway, bit of a sidetrack, still. Okay, so we're going to calculate the midpoint, and then I want to say if the sort value is equal to numbers array at the midpoint. Well, in that case, yay, we have found it, so we can say print f number found at index and it was found at index mid. Okay, I just need to pause 1 second. Does sound like dogs dying outside? 1 second. Okay, no problem with the doggies. So anyway, so if the sort is equal to the numbers at mid, then we found it. If we found it, we want to change our found to be true, which means we're going to stop this loop. So when we find it, we exit the loop. However, if we don't find it, well, like we said before, if the number we're looking for is less than the current value at the index, let's see, where is it? I can't find my thingy, and my dog's attacking me inside here. Okay, so we said that we're going to the midpoint. If we were looking for 4, then 4 is less than that, so we can exclude all of these values. Okay, so what does that mean coding-wise? Well, that means we can set the upper equal to the mid minus 1. Why minus 1? Well, because we've checked this value. When we were doing our check, we've included the midpoint, so we can subtract from the mid as well. Okay, well, not subtract from the mid, sorry, that's a terrible way to say it, but we can exclude the mid, so we're going to do the mid minus 1. It's going to be our new upper value, so we're going to have this as our new array. Okay, now that's only going to be true if the sort number is less than the numbers at mid. Very important point. If it's not less than, or which automatically means greater than, then the lower is going to become equal to the mid plus 1. So let's say we were looking for the number 12, and we go to the midpoint, which is a 9, so it's greater than 9, so we can therefore exclude all of these, which means moving our lower value to be 5, because that's going to be the bottom of our new searchable array. Okay, again, don't want to dig too deep into the theory, but it is important to look at it. Alright, so I think that should work. Fingers crossed. Enter number defined. Let's look for the 3. Oh, stringing in. What have I done? If sort is less than numbers mid. What did I do? Oh, I forgot to change that to an int input. Sorry, that's really bad. There we go. 3. Yay, so it's found at index 1. Yeah, so all I'd done wrong there was I forgot to change the data type of the input. My main language is actually Java, so I've got I sometimes forget a lot of stuff when I'm doing Python, and int is a bit of a weird one. Anyway, so what else do I need to check? Well, I also need to check that some other numbers. Let's try 100. Let's try boundary data. Yay! Found at index 7. Now, what's not going to work is if I look for a number that is not in the array. So let's say I look for 8. I get stuck in an infinite loop. And that's not good. So I'm 90% of the way here. But I also need to think about what condition do I stop looping in when I've searched through everything. And if you think about it, what you're actually going to have is an and you're going to say and the lower is less than the upper. So while it's not found, and while the lower is less than the upper, then we're going to keep searching. Let me check that, see if I've messed it up. bit tricky one brain-wise. 4, yay! But let's search for an actual number as well, because that's going to cause us problems. Let's look for 21. Yay! Okay. So that's quite good, but then after the loop, I want to say if not found, then print sorry, not found. Okay, so if it's not in the array, so if we finish our loop and not found is still set to false, then we know that we did not find the number. Now, what people find a bit tricky here is this statement. And as you've seen, I had to stop and think about it. If you do it a lot, it gets easier. You only look at it once or twice a year. It's hard to get your brain around a bit. So what's that all about? Well, think back to your logic gates. So you should all be logic gate masters by now. And we have an AND gate. And our AND gate is the same as what we're doing in our code. We're doing an AND. With an AND, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 is 1. So when we do these conditions and we're finding them difficult, we have to write them out into their logic, and then it starts to make more sense. Okay, so we've got two inputs, we've got A and we've got B. And we've got input B. Okay, and that's A and B. Now for A, we have said that found is equal to false at the start. Now, for those of you who know this, false is a 0. However, we have said not found. So therefore, not found is equal to a 1. B, on the other hand, lower is less than the upper. So basically, if the lower goes above the upper, or the upper goes below the lower, then we know we've searched through the whole array. So let's start with lower is less than upper. So B is equal to lower is less than upper. Now lower is 0 and upper is 7, I think, at the start. So therefore that is going to equal a 1. Now taking these two values, a 1 and a 1, were this to be put into an AND gate, we would get a, so let's say here, let's say we put it into an AND gate, our x is going to be equal to 1. So what does a 1 mean? It means keep repeating. Okay, so if it's not found and the lower is less than the upper, keep repeating. Now, if it were found, then found is going to become equal to true, which is going to equal 1, which means that not found is going to be 0. 0 and a 1 into an AND gate stops the loop. Okay, okay. So, but let's change that back. Now, in the condition where the lower is greater than the upper, which means we've gone through all of the items in the array, then that's just going to change straight away to a 0, and a 1, 0 also means we end the loop. Okay, so if you get stuck, with these, just draw it out as a truth table, and it will actually make a lot more sense. Okay, hopefully that works and is helpful. If you get any questions, then please let me know. Thank you.